Question number 2 for periods of simple harmonic motion. A block of mass 50 gram is attached to a light helical spring with a force constant of 2.5 Newton per meter. The block is free to oscillate on a smooth horizontal surface. The block is displaced 6 centimeter from the equilibrium position and released. Okay, good. Yes, things we have here is mass. Take note, it's in gram, not SI unit, so we need to change to kilogram. Okay, in fact, I changed already. Okay, we have mass, we have the force constant, this is the K, free to oscillate, and then this sentence is very important. The system seems to start from the amplitude. Okay, the word displaced here, he said displaced 6 cm from the equilibrium position and release. Okay, first thing, there are two things we need to take note here. He said displace 6 cm and then release. You displace something 6 cm and release. Means the 6 cm become what? What does it become? You displace 6 cm, then the object will start to oscillate with also amplitude 6 cm, isn't it? You displace 6 cm, will the amplitude become more than 6 cm? Become 10 cm? Or in other words, you pull 6 cm, it oscillate with 6 cm, or will you pull 6 cm, it oscillate with 10 cm? That's not possible, right? You pull, how much you pull, then it will oscillate with that much. You pull 6 cm, then it will also oscillate with amplitude 6 cm. So what, in short, what I want to say is, how much you displace is how much your amplitude. That's your maximum displacement, 6 cm. So the word displace means how much you pull will be how much your amplitude. Understand that? How much you pull is how much your amplitude, how much your maximum displacement. So that's the amplitude, 6 cm. And it is cm. One thing, the unit, be careful, this is gram. The Newton meter, never mind. Okay, the cm. You need to change to SI unit, meter. Okay, be careful. Another thing to take note is, it displays from the equilibrium position and release. Release means once you release, the time start, because the system start to oscillate, isn't it? It start to oscillate. So at 0 second, that means once you release, the time start, the clock starts ticking. So that means once you release, the time starts and the block is oscillating. So this means that these things oscillate. This oscillation does not start from equilibrium position. It starts from the amplitude, the place you displace, which is 6 cm. So the formula of this is not we can say this system does not follow A sine omega t. No. But it has, for this case, it has what we call the phase angle, initial phase constant. So what happens is this one. It starts from amplitude. Okay? So it release. At the moment it release, the system start oscillate from the amplitude. Okay? So I already written here, yeah? I already written here. So at 0 second, the displacement is at amplitude. So the system actually start to oscillate from the amplitude. The system does not start from the 0 displacement. It starts from the amplitude. So at 0 second, the moment it displace, the moment it release, it starts from the amplitude. So it oscillates. So it becomes actually a cos graph. I become a cost graph. If we still insist want to use a sine equation, yes, but we need to include the initial phase angle, which is pi over 2. Phi, this is called phase angle. Pi over 2, which is called the initial phase angle or called phase constant. Why we have phi in the formula? Because at 0 second, the displacement does not start from 0. So it has a certain initial phase angle called phi. And our phi is pi over 2 radian. Okay, pi over 2 radian. So actually the equation is x equal to a sine omega t plus pi over 2. But if you use trigonometry, you know, if you use trigonometry, you try and derive this a sine omega t plus pi over 2, you will get cos omega t. You get actually a cos graph. Okay. So at 0 second, it starts to oscillate from the amplitude. Okay. So actually, it's a cos graph and cosine equation. Now, okay, let's start our questions. So we have the mass. I changed to kilogram already. The force constant is 2.5, and the amplitude, okay, is 6 cm. So the word, how much it displays. The word displace means amplitude. How much we displace, then it become our amplitude. Okay. So 6 cm. So convert to meter. Convert to SI unit. Divide by 100 is 0.06 meter. Okay, so we want to find the period of oscillation now. This is a spring mass system. So the formula is 2 pi square root m over k. Okay. So do we have the mass? Yes, we have the mass already. 0.05 kilogram. And k is 2.50. So what is our period? What's our period? Our period is 0.889 second. That's our period. Now, what is our maximum speed? Maximum speed formula is A omega. So we don't have the omega, but we have the period already. We need to find the omega first, which is 2 pi over period. So 0.899 for the period. And what is our omega? So our omega is 7.0677 radian per second. That's our omega. So our amplitude is 6 cm. How much we displace is how much our amplitude. I already convert to meter. So that is 0.06 meter. Then 7.0677. Okay. So what is the maximum speed? 0.424 meter per second. Yes, that's our maximum speed. Now, what is our maximum acceleration? Maximum acceleration, A omega square. The formula A omega square. So just use our amplitude and omega we got just now. Amplitude is 0.06 meter. Omega is 7.0677 square. Square. So the answer is 2.997 meter per second square. That's our answer. Now, we got our maximum speed and maximum acceleration. Yeah, that's correct, the answer. Now, determine the position of the block. Determine the position of the block at this time, 0.5 second. Okay. The question asks for, lagging. So the question asks for, give me a second. All right. The question asks for position. That means he asked for displacement. Okay, at this time. So we need to use the displacement time equation. Okay, displacement time equation. Do we have any displacement time equation? Not yet. But Yes. Just now what I said is the block start to oscillate from the amplitude, isn't it? So the graph is a cosine graph. The graph is a cosine graph because it start to oscillate at the amplitude. You see, at 0 second, at 0 second, at 0 second, the x is amplitude. Because it displays until amplitude, then release, isn't it? Yeah, this is the moment you release. You release at 0 second, then the time start. Then the system start to oscillate from the amplitude. So it become a cosine graph. So in terms of the initial phase angle, if we still insist want to use a sine equation, we have a phase constant called the pi over 2. If you use trigonometry, use the sine a plus b becomes sine a cos b plus cos a sine b. You will get this equation, cosine equation. Okay. Okay. Now, good. So, in other words, our displacement equation is a cosine equation. Okay. So, do we have the amplitude? Do you have the amplitude? Yes, it is 6 cm, which is 0.06 meter. So, in fact, this is 0.06 meter. Okay. So we already have the amplitude 0.06 meter. Now, do we have the omega? Yes, we have the omega. Omega is in SI unit. Okay, omega is in SI unit second. Okay, so 7.0677 T. Okay. So just now, what's the unit? When you give equation. Okay, when you give equation, make sure you know the unit. X in meter, T in second. Because all this while is all in our amplitude is in meter. Yeah. So our amplitude is in meter. So our omega is also second per second. So that's why our X is meter, our T is also second. Okay. So make sure all in SI unit. Now, we want to find the position of the block at this time. So we use this equation to find. We use this equation. So put the time there. So what you do is you substitute the time. You substitute the time with 0.50 second. Okay, so and then we can get the position, the x. X is equal to 0.06 cosine 7.0677 times 0.50 second. So our x is equal to, what is our x? Our x is equal to negative 0.0554 meter. Okay. So is meter, why? What is meter? Because x is in meter, because our amplitude already in meter. You see, our amplitude is in meter. So our x also in meter. So if you want to convert to cm, just multiply by 100. So it is multiply 100 is 5.54 cm. Be careful. Yeah, the negative sign also must include. Negative sign means negative displacement. Okay, is that the answer? Yeah, displacement is negative 5.54 cm. Okay. So be careful with the unit. All right. So in short, what I want to say is, how much you displace is how much your amplitude. Okay, the amplitude won't go more than how much you displace. Okay. All right. And if you displaced, if you release from the amplitude, if you release from the amplitude, if the time starts from the amplitude, then your equation is a cosine equation, because if you release from the amplitude, it is a cosine graph. Okay? And that's all for these questions. See you in the next question.